Welcome back to our series on Python Made Easy. Today is a very exciting day. We're going to look at the wonderful world of iterators. We'll talk about what an iterator is, how to use them, what they're useful for, and what makes them special. We will then dive into no less than 28 key iterators in the Python language. We'll talk about what distinguishes one from the next, and we'll be chock full of examples as always. What is iteration? Iteration in the context of computer programming is a process wherein a set of instructions or structures are repeated in a sequence a specified number of times or until a certain condition is met. When the first set of instructions is executed again, so we go through it for the second time, this is known as an iteration. When a sequence of instructions is executed in a repeated manner, this is called a loop. So we see there is a relationship between iteration and a loop. So stick with us. Now we're going to Pythonify it in the slides that come up. Before we get to how this is carried out through the Python language, why do we iterate things to begin with? Here, computers mimic life. Many things in life come down to repetition, whether it be washing a dish, folding an article of clothing, doing certain exercises, reading a page in a book, whatever. Computers excel at repeating tasks without making mistakes. So we iterate to make the mundane tasks more bearable and also to make things easier, better, faster, and less error-prone. We repeat or iterate things because there is a need or it makes good sense to do so. Now, what are Python iterators? Python iterators are objects that represent a stream of data and are capable of returning that data one element at a time. It must support a method called next, which takes no arguments and always returns the very next element in that stream. And it must be able to raise the stop iteration exception when there are no more elements in the stream of data to act on. The stop iteration exception is raised by the built-in next and the iterators next with the double underscores on either side, methods, to signal that there are no further items produced by the iterator. And now we start our exhaustive look at the 28 different iterators, including in this module, which is darn near all of them. What are the objects that iterate or are used with iterators in Python? So the first thing we'll look at is the built-in iter function. It takes an object and returns an iterable of the object's content. So let's look at the code. We have a tuple of 4 elements, the numbers 1, 2, 3, and 4. Then we set a variable and we use the iter function on that variable. And you see what happens is we have to call that next method that we spoke about on the previous slide to make each one of those appear in the output of our code. The next method, as you'll remember, always returns the next item in the list. The next method also returns that stop iteration exception when there are no more items in the list to go through. So you see in the output of code, with our successive print statements, it prints 1, 2, 3, and 4. And I purposely printed a 5th where I knew it would fail to show you that it raises that stop iteration error and says, hey, there's no more here. So we can think of this in this way as manual iteration. We must force that next element out by calling the next method. If we move to the right, if you've been with me during the tour of this Python Made Easy series so far and you're taking them in succession, you know that we had a course on for loops. So this is nothing more than a for loop. So this is going to take what we just did, but in an automated fashion because we'll employ the loop. So the item in the tups position, tup is my variable of tuples, must be iterable. If it's not, then Python will also throw you an error. But assuming it is, we do for item. An item is that iterator, right? That thing that's going to represent each of the elements in our iterable. In tup, which is our iterable, print the item. And it does just that. We don't have to automatically call next. This all happens in an automated fashion. So it prints out 1, 2, 3, and 4, just like we would expect. Next, we've also discussed list comprehension to the right-hand side in our previous courses on lists. So here we have a list instead of a tuple, and it contains the same 4 elements, 1, 2, 3, and 4. Then mult underscore list, we're going to multiply each element in that list using list comprehension and then output, in essence, a new list. So I times 4 for I in list 1 as, a typical syntax for list comprehension. So it's I representing each one of those elements times the number 4 for all of those in list 1, and it outputs, instead of 1, 2, 3, 4, the multiplied version, 4, 8, 12, and 6. On this slide, we'll look at 3 other iterators. We'll look at generator expressions, generator functions, and filter functions. Now, I should tell you that we'll have a whole class on generators themselves because they're that important. But here, let's take a peek at the generator expression. Every generator is an iterator, but a generator doesn't return a single value. Instead, it returns an iterator object that may be iterated upon one element at a time. Generator expressions look really similar to the list comprehensions we just saw, but instead of the square brackets, they use parentheses. And it returns that generator object, which we must do something with to extract the individual elements. So we have an option. Here we see list 1 equals 1, 2, 3, and 4, and the same expression that we had in list comprehension for our variable mult_gen. I times 4 for I in list 1. So we see, the first thing we do is we print out the type of this object mult_gen, and we see it's of class generator. And then to extract each, we of course could use next, but that's not very handy. So we go down to our second version and we say for x in mult_gen, our generator expression, print x, and then automatically it prints that out. So we can think of generator expressions as on-the-fly generators. Then we can move over to the generator function. So what's the difference here between the two? A generator function is a function that contains one or more yield statements. When it's called, it returns an iterator object, but execution must be invoked by the next or iterator function. Unlike regular Python functions, generator functions allow you to resume where the function left off at a later time, which can be very handy. We didn't get to functions yet in this series, but with functions, we have a return statement, and the return statement returns the object back to the caller. There can only be one, and once that happens, the function is over. That's the end. But with this one, we can come back and we reuse. So how does it work? We can come back and pick up where we left off. So that's fantastic. So we define one simple generator and we yield 3 strings, happy, joyous, free. To call on that next function over and over, we can use a for loop like we have here. So for x in our generator function, one simple generator, print x, and it prints out happy, joyous, free, as we would expect. So we can think of generator functions as reusable or suspended functions. Then finally, we get to our filter function. Here, a filter takes 2 arguments, a function that tests if each element of an iterable returns true, and the iterable, which will be filtered based on the specified code within the function. So what happens here? We define a function, define secret numbers, pass it the parameter x. If x in secret, return x, else return, and return with nothing in it will return null. My list is 10, 15, 20, 25, 30, 35, and 40. So x equals list, filter, we apply the filter, secret numbers, my lists. So we only want it to return whatever those secret numbers are, and we set that up top, which is 10, 20, 30, 40, 50. When we evaluate my list against those list of secret numbers that's used in our function, we see that it only will print back a subsection that are in our secret list, 10, 20, 30, 40. And on this slide, we'll look at the mapping function, the enumerate function, and the sorted function. So let's start with the mapping. Mapping returns a list of results after employing a function to each item in an iterable. So we'll look here at the code. We have defined our own function, add me. It takes a parameter val. We return val plus 100. Then we have a tuple, numbers equals 1, 2, 3. Then we have another variable map it where we use our map. That's map. We pass it add me, our function, and then our iterable numbers. And when we print that out, we see that we get 101, 102, 103, and we print it out and type convert it to a set in this particular case. Next, we have our enumerate function, and we've used this throughout the course before. So what does this do? This returns the element in an iterable and also indexes each of the elements. So here we have a tuple, yo, we have yo, yo there, yo buddy, yo, 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 all strings, 4 strings. So now we have for y and enumerate, yo, and 1. That 1 tells us to start at number 1 with our indexing, and it outputs just as we expect, the 4 values with 1, 2, 3, and 4. Next, we have the sorted function. This sorts the elements of an iterable. So we have a list this time with 5 elements in it, all different animals. So we have sort me as our value. We pass the sorted function, the iterable, and we also use the keyword reverse to true, so it does it in reverse when we print it out. We have zebras through camels, so it's in the reverse order. And here we'll look at the any, all, and zip functions. Let's start with any on the left-hand side. This returns true if any of the elements in the iterable are true. So we have 2 lists, my list equals false 0, 1, and my list equals false 0, none. Now remember, false and 0 and none, their values return false in Python. 1 will return true. So when we look at print any my list, the first one, it's true because 1 does evaluate to true. When we look at my list 2, false 0, none is false because none of those evaluate to true in Python. Then we have the all function in the middle, returns true only if all of the elements in the iterable are true. So we have my list false 0, 1, same one, and then we have yes, 1, and time. Yes, 1, and time will evaluate to true in Python. So the first one, when we print out all my list, it's false because they're not all true, only 1 is true. And the second one evaluates to true because they're all true. And finally, on the right-hand side, we have the zip function. It takes 1 element from each iterable and returns them in a tuple unless you force the type conversion to a dictionary or another type like we did here. So we have list 1 and list 2 of a bunch of numbers. We have a new variable called me_new equals dict zip, zip up the 2. Then we print that out. It's going to print out in the form of a dictionary because of the dict type conversion, the dict method we call here, and you see how it does it. It's a great way to create a dictionary on the fly. Now, the whole rest of the presentation is going to be dedicated to this Itertools module. This is really the heart of this iterator presentation. So what do the Itertools do? This module is part of the Python standard library. It contains several commonly used iterators. On this slide, we'll take 3. Count, cycle, and repeat. So let's start with count. So look at number 1. We have a for loop. Islice, actually we're going to look at that later in this same presentation more specifically, but we're looking at it now in concert with the count method. So islice returns an iterator which returns a subset of elements from that iterator by using slicing. Count returns an infinite stream of evenly spaced values. If we didn't take a slice, this would just go on forever. That's why we're using the islice method. End here, of course, is just used for printing purposes so that it all prints on one line. When we do end equals and then open quotes, it prints all on one line instead of on successive lines. It's just easier for us to fit it given the real estate we don't have on the page. So that's what that does. And mind you, at the top of all of these, whether I have it here or not, we have to import a star from Itertools. We can do these individual methods, but it's easier for us for training purpose to do from Itertools import star. So they all come in. Next, we have cycle in the middle. So cycle takes an iterable as its only argument and creates a new iterator that returns its elements from first to last. I stop the cycle by using an if statement with a break when the count reaches 25 elements from the cycle iterator. If not, this too would go on forever and ever and ever. So that's why I use a break here. I use a slicing technique in count. You have to do something, otherwise it'll go on forever. Unless that's what you want, then have a party. Then we have repeat here. So repeat takes elements and returns them a fixed amount of times. In our case, we're specifying 6. It will take just about any Python object here, string, integer, tuple, list, set, function, whatever. So what we do is for x and repeat, we have my set, which is a set. We're saying, hey, I want you to repeat 6 times. Again, we use n to print out all on one line, and you see how it prints down at the bottom. It prints this set of data 6 times. We are still in the Itertools. We're looking at chain, islice, and t. We'll start with chain on the left-hand side. chain takes multiple iterables and returns each element of each iterable in order of how the iterables were supplied to the chain method. So we'll look at the code. We have list 1, tuple 1. Each has 3 elements in it, 1, 2, and 3 for the list, 2, 3, and 4 for the tuple. Then we have a set of 3 strings, A, B, and C. We do for x in chain, list 1, tuple 1, set 1. We print those all out, and we see that they print in order of appearance. We fed list 1 first, so 1, 2, and 3 comes out. We fed tuple 1 second, so 2, 3, and 4 comes out. And then, of course, not in any set order because sets don't work that way, but the 3 characters in the set print last. Then we go over to islice. Islice, we saw this before. We used it with count, I believe. Islice takes an iterable as its first argument. Then it takes the usual slicing start, stop, and step. You can't use negative numbers with islice. That's a constraint. So here in the code, we have list 1. We have numbers 1 through 9. For x and islice, list 1, 1, 9, 2. So 1 is the start, 9 is the stop, and it's non-inclusive, so we won't take that index. And then the stride or the step is 2. So we'll take every other one. It prints out 2, 4, 6, 8. It starts at index 1, which is number 2. That's why we get the 2, 4, 6, 8. Then we go over to T. T is very interesting. T returns several independent iterators. It defaults to 2 based on a single original input. I set one of the iterators to output to the screen and the other iterator to output to a file. So we have my list, A, B, C, and D, 4 strings. Screen and file equals T my list, both set to the same thing. So for I in screen, print to the screen, I. And then I go through a my underscore file equals open. I create the file my underscore file.txt. I pass it the W parameter. For I in file 1, print to the file, and file equals my file, and then I close it always so that we flush out that data. Otherwise, it's a good chance that it doesn't get written. So you see the code output for number 2, which is to the screen. It prints to the screen A, B, C, and D 4 times, and then to the file. So it goes, in one shot, it goes to 2 completely different places. Very handy, especially for administrative work. Still in the Itertools, we're going to look at startmap, filterfalse, and takewhile. We'll start on the left-hand side with startmap. Startmap takes a function as its first argument and an iterable as its second. It assumes that the iterable will return a stream of tuples and calls the function using these tuples as its arguments. So we'll look at the code. My tuple, what do I have in there? I have a list filled with tuples. Then I have variable x equals startmap, my function, os.pathJoin, and we have a whole class on join, and os.pathJoin is in there as well. And then we have my tuple, our iterable. So when we print that out, it concatenates those 2 lists together. And notice it puts the slash in front of it from the os.path.join. So dir1 / file1, dir2 file2, dir3 file3. Another thing that could be extremely useful for administrative purposes and other applications. So now we have filterfalse. Filterfalse is just the opposite of filter that we saw a few slides earlier. It returns all elements from the iterable for which the outcome returns false. So it evaluates to false instead of true. So let's look at this. We create a function of our own called less than 20 with a parameter of x. We return x less than 20. So my list is a list with a bunch of numbers in it, 1 through 40. My filtfalse, or my underscore filter underscore false, equals filterfalse less than 20, comma, my list. So less than 20 is the function. My list is the list right above this. So for x in my filtfalse, print x. So what does it return? 20, 30, and 40, because we're saying return if it's less than 20. If it was filter, it would do that. But it's filter false, so it's like, oh yeah, I'm going to do the exact opposite, so it returns 20, 30, and 40 instead. So filter false. And then last but not least, takewhile. Takewhile returns values from the iterator as long as the function returns true. Once the condition is no longer true, the iterator will signal the end of its results. So again, we're going to use the same thing here, our same function that we created, less than 20 with passing the argument or the parameter of x, return x less than 20. My filterfalse, we should have changed that to takewhile, but nevertheless it's doing that, equals takewhile less than 20 and then count. So for x in my filterfalse, print x and then comma n to have it print out all on one line. So it's just going to print less than 20. We're just going to have it count. So it prints out 0 through 19. Okay, so that's kind of doing the opposite of filterfalse. It takes it while it meets the condition and the function is dictating that, and x has to be less than 20 and 19 is less than 20. And here we have dropwhile, compress, and combinations. So we'll start with dropwhile. We have a function, same one, less than 20, return x less than 20. So my list equals a whole bunch of numbers. My drop equals dropwhile less than 20, my list. So dropwhile will drop those elements from an iterable while they evaluate to true. When false, it will output the rest of the iterable elements that are not true, in other words. It's kind of like the filterfalse in that respect. It says, okay, less than 20, I'm going to drop. Right? Instead of filterfalse, it says I'm going to drop those things that are less than 20 and print you out the rest, which is exactly what it does. Then we have compress. Compress takes two iterators and outputs those elements in the first one that have a corresponding true evaluation in the second list of iterables. So it's kind of like key value here. Note, I'm using 0 and 1 in the second list. 0 in Python, of course, will always be false and 1 will be true. So our list 1, 2, 3, 4, 5, 6, 7, list 1 that is, and list 2 0, 0, 0, 1, 1, 1, 0. So now it'll take each one of those and pair them up, right? So my underscore comp equals compressed, list 1, list 2. So for x in my comp, print x. So it should only take those that evaluate to true. So does 1 evaluate to true? No, that pairs with 0, the first element in that list. So that's false. 2 is false. 3 is false. 4, 5, and 6 are all true because they correspond to the number 1, and 7 is false, so it prints out 4, 5, and 6. Mission accomplished. All right, combinations. So what do we have here? Combinations takes an iterable in its first position and finds all the possible combinations of the various elements from the iterable of a given length dictated by the number in its second position. In our case, the second position is 2, right? The first position, we have list 1, our iterable. And when using combinations, the order of the tuples mimics the iterable. That is, it maintains its order when outputting. So to the code, list 1 equals a list of 4 numbers, 1 through 4. X equals combinations. First position, we take the iterable. The second position, number 2. So what length do we want to have it create the combinations? For I and X, print I. So you see it does just that. In groupings of 2, it prints all the possible combinations. And here we'll stay with the theme of permutations or combinations from the last example. So permutations and combinations with replacements. Permutations, first example up at the top. It's exactly like combination, except that the order does not have the constraint of being maintained. It also doesn't require that the elements of the iterable be unique, which could be very handy. So here we have list 1 equals 1, 2, 3, 4, x equals permutations, list 1, for I and x, print I. And you see it comes up with all the possible combinations or permutations for those 4. Combinations with replacements. So how is that different than the straight combination? The first argument is an iterable of elements, and the second is the length of the pairing combination you wish to make from them. In our case, the length specified is 2. Note, it replaces the first element of the pairing with the next element in line inside the iterable. It does so until you are left with just one number that only pairs with itself. So look here, this is easier to see it. It goes through our list. It starts and pairs 1 with itself, then 1 with 2, then 1 with 3, then 1 with 4. Then it eliminates 1. Now the first element is 2. 2 pairs with itself, then 2 pairs with 3, 2 pairs with 4, then 3 pairs with itself, then 3 pairs with 4, and finally the only thing that's left is for 4 to pair with itself. So it's combination with replacements. We're getting to the end, folks. Here we're going to talk about the zip underscore longest. Zip longest takes any number of iterables you give it and combines them all together For any that are longer than another, it'll compensate for those shorter ones by adding a fill value object. Okay, and on the left-hand side, my fill value in the code output was dash dash. On the right-hand side, I show you an example where I ran the code again, and I passed no fill value keyword. I didn't use it. In that case, if it has lists that are not equal, it's automatically going to put the word none. And that's what you see there. So for I and zip longest, I have 4 different elements. I have 2 lists and 2 strings. My fill value the first time again was dash dash. So you see how it prints out. The longest element there is 5 characters long. So it has to compensate for all the rest of them. It takes 1 from each. The first position from each is 1A, 4H. Second time we're still good. 2B, 5E. Second time 3C, 6L. Now we get into trouble. The 4 is good. We have nothing from the second list. 7's good and L's good. And the last time around, we've exhausted everybody except the last O in the string hello. So that's how it works. Pretty neat. And we are down to the last method that I have from this Itertools module for you. So accumulate. Accumulate makes an iterator that returns accumulated sums or accumulated results of other binary functions. It takes an iterator and a function. So let's look at the code. We import iterator tools and operator here. So list 1, 2, 1, 4, 6, 8, 10, etc., etc. Then x equals list accumulate. List 1, we pass it as the first argument, and max as our function. And you see what it prints out. 2, 2, 4, 6, 8. So it evaluates each one of these against the one after it, and it says, are you larger? Are you larger? And it keeps going until it gets a larger number and takes that output. We do the same with the min, and it does the same thing. It takes in 2, then it evaluates 2 against 1. Oh, you're less. Against 4, you're less, and it just stays with 4 the whole rest of the way. Pretty neat. The second example, what do we do here? We have nums 2.5, 1.7540, 12.25. And now here, for x equals list accumulate, nums are list of floating values and then mul. The mul function used with accumulate loops over all values, multiplying each one to the next. So 2.5 times 175 is 4.375, and so it goes. So it just multiplies them all against each other. Then in the next example, we have nums again, 4 different numbers. X equals list accumulate num sub. And sub function used with accumulate, I bet you can guess what it does. It loops over all values, subtracting each from the previous. And finally, we have the concat. I bet you can guess what that does too. That concats each number of the list to the one after it. So we have catfish, frogs, clams, and roosters. And the output is catfish. Well, starts with cat, then catfish frogs, then catfish. It's like a game of telephone. Okay, and for the last one, we're still on accumulate. We're going to show you a more complex example, and then we're going to see it in action in idle so we can actually see how the code traverses. So we're going to create an amortization calculator. The loan principal is $10,000 at 2.5%, and the payment every month is $261. So we have amor equals list accumulate, our accumulate method. We feed it payments, that list, and then we feed it a lambda. We haven't seen a lambda function yet. We haven't gone over lambdas, but we will get to that for sure. But for now, lambda, we pass it the balance, which is going to be the $10,000, and then we craft a payment variable, balance times 1.025, which equals our 2.5% plus the payment itself of 261. We then set a payment variable to equal 0. For pay in amor, where we're using our accumulate method, we'll print out the successive loan amounts as we make each one of those payments. So let's go straight away and see this in action. Okay, so let's see how this whole accumulate with the lambda function works. We're gonna be in debug mode and idle. So here we go. We'll kick it off. We already see what the output is there, but we kick it off with F5. Let's make this a little bigger so we can see. We read the import. We step. We read the list, the payments list. All right, now we read the amor statement. Now you see balance for lambda is grabbing 10,000 and the payment is the negative 261. Now it should calculate and it should traverse. Then we have a new balance, and then the same payment, a new balance, same payment, new balance, and it goes like that. Let's see if it does. Yeah, new balance, same payment, new balance, same payment. We just do all the outs, and there it is. Just traverses right through.